Tapi yang menarik kalau kita dengar dari Profesor Michael Northcott, karena beliau itu pengajar di UGM, dan beliau mempresentasikan presentasi dia di depan rektor, depan semua mengenai proyek yang dilakukan di UGM. Jadi kalau saya kan nggak langsung, kalau dia kan langsung. Mungkin ada baiknya kalau diizinkan oleh Pak Kun, Michael, can you explain whether about your presentation in the UGM Senate that you are opposed with that, and most of the lecturer that.
Yeah, thank you very much. Yep, thank you, Richard, for the invitation to join. I will speak in English. I will speak slowly, and many of my words will be on screen, so that will hopefully help. I was professor of ethics at the University of Edinburgh. I still am a emeritus professor there. I'm an adjunct professor at the graduate school. I'm mainly the doctoral supervisor. I conduct research on religion and the environment. And over many years, I have conducted research on the religious, but also the ethical implications of genetic Mosquito Program. Professor Uttarini is described in Nature Medicine as a mosquito commander. She is the lead scientist at UGM, medical faculty, on the World Mosquito Program. And her work has turned Yogyakarta into the poster child of the World Mosquito Program. They claim that the project in Jogja has resulted in a 77% reduction in Yogyakarta of dengue infections, and they claim no other effects, no bad effects. We'll come back to that. You've already heard about the World Mosquito Program and its very grand intentions to spread to many other countries. You'll see that there's a huge amount of money involved, and you'll notice that Bill Gates is one of the key people behind it. The World Mosquito Program is a group of private companies which are biotech spin-offs from Monash University, Australia, primarily funded at the beginning by the Bill and Melinda Gates Foundation. The program claims it intends to reduce all mosquito-borne diseases such as dengue, Zika, yellow fever, and chikungunya. It has been working in particular to introduce Wolbachia into Aedes aegypti mosquitoes to prevent the transmission of dengue and other mosquito-borne diseases. The program is funded by the Wellcome Trust, USAID, DFID, and the Bill and Melinda Gates Foundation, and more recently the Australian government through CSIRO. It's widely reported in mainstream journals that the program is already successful, and there are 2 peer-reviewed journal articles indicating particular success in Yogyakarta. The first, the successful establishment of a Wolbachia strain of Aedes aegypti population in Yogyakarta. These are said to be a weakened strain of Aedes aegypti, and when they breed, they lead to a reduction in numbers and a decline in dengue infections. There was then a pilot study done of individuals living in the project area in Yogyakarta whose blood was examined compared with individuals living in other parts of Jogja, and they found a 77% reduction in dengue infection in the period when they conducted this pilot study. And there are media reports of reductions in dengue cases and hospitalizations in Yogyakarta, which, as you can see, also repeat the New England Journal of Medicine article. However, the government's own statistics on dengue in Yogyakarta are a little interesting, let's say. You see a huge increase in dengue infections immediately prior to the launch of the World Mosquito Program in Yogyakarta in 2011. I have yet to have this huge increase explained to me. In the government's report on Jogja, we see another huge increase. We see 3 here, but a particularly massive increase immediately prior into the community on a large scale in 2016 to 17 and 18. And again, I've had no explanation for why this should be, but it makes the project look very successful, because you go from a huge peak to a significant drop. However, if you look at the period as a whole, you see that, broadly speaking, very little has changed. Despite this huge amount of money and the alleged success, the numbers with serious dengue in Jogja area now are pretty similar to what they were before the program started, if not a little higher. So, but most recently, as Professor Klaproth mentioned, the project in Jogja has moved to Kulon Progo, which is the area around the Yogyakarta airport to the west of Jogja city. And at the very time when this new embryos were released, there is a sudden outbreak of Japanese encephalitis reported in Kulon Progo in the media, which is unexplained. It's never occurred to my knowledge before. And this, to say the least, is concerning. Bali, I discovered, is another location in Indonesia where there's been a significant increase in Japanese encephalitis in recent years. The increase in Bali is clearly coincident with the decision of the health authorities here to begin vaccinating children against Japanese encephalitis in 2018. Deaths occurred in some villages in Bali during the rollout of that max vaccination program, and international media started to report on this as a risk, and people were being told, tourists, that they needed to get vaccinated against it. Well, as a professor of ethics, I have a number of questions then about World Mosquito Program projects in general, and in Jogja in particular. I'll run through them quickly. Why did the infections increase 2.5 times just before it began? And again in these other two sectors, but now they seem to be normal again, though this normality is attributed to the World Mosquito Program project. Why did Japanese encephalitis suddenly emerge in the project area during the release of modified mosquitoes? The scientists claim a 77% reduction, but only in the pilot area. There's no discussion in their papers of these anomalous increases. I wonder whether traditional control methods were reduced to improve the outcomes. This is an ethical question. I don't have an answer to it. I'm not saying it happened, but I'm simply asking the question, why did we get these huge increases in dengue immediately before and during the project, which make it look very successful? Success against dengue in Jogja is the justification for massive releases of Wolbachia in other parts of Asia, including Singapore, which has also seen a big uptick in dengue, Sri Lanka, another big uptick in dengue since the program began. And now they want to spread it to Bali, Central, West, and East Java. Well, I find it very odd. Whenever you look online in Google at the World Mosquito Program, you see wonderful positive reports, but you don't see reports of these doubling of dengue infections in Singapore and Sri Lanka, but they're clearly there in the media. They are out there. I haven't made them up. But there are also ecological questions about the World Mosquito Program. The scientists say Wolbachia modified mosquitoes are natural, but Wolbachia bacteria do not naturally occur in Aedes aegypti mosquitoes. The male Wolbachia are modified by microinjection to infect adult mosquitoes with Wolbachia bacteria. These male bacteria are then utilized to infect female mosquitoes. Therefore, we have a genetically transmissible trait out in the wild. Now, whatever you say, in the proper understanding of genetic engineering, using techniques like microinjection, this is a genetically engineered release. Some argue it's a covert gene drive. So a gene drive is an attempt to wipe out other species with an engineered species. Such gene drives are already occurring in Florida, in Brazil, and in many other places. And they have been accompanied by an increase in illness. Well, again, if we look at the journal articles, they're quite clear that these World Mosquito Programs involve genetic control techniques. There's no doubt about this. They're called symbionts, and yet the public relations campaign of Bill Gates, of the World Mosquito Program, and so on, claim that their mosquitoes are natural. They are not natural. If we look at the latest island to be plagued with the World Mosquito Program, is Sri Lanka. And in 2 years, they've had a tripling in dengue infections, according to newspaper reports, which are now 3 times higher than they were before the World Mosquito Program began. It isn't only one isolated article. There are many articles reporting these increases. And these strange increases in illness in World Mosquito Project areas are not isolated. There are a number of other projects around the world where World Mosquito Program projects have led to problems and increases in disease, and are described in media as having backfired. Japan, most notably, but also Brazil. The Brazil project is actually being run by Oxitec, which is a British company, a spin-off from Oxford University with big backing from the British Development Aid Agency. And this project has accompanied a significant increase in illness in Brazil. And it has spawned apparently hybrid infections, insects in Brazil, which are more resistant to traditional control methods. And then the same company has been active in Florida and Texas. And in Florida Keys in particular, there's been a huge increase in dengue of 1,000% since the program began 2 years ago. The program met with much resistance in the community, and yet it went ahead. There were only 3 cases of dengue in Florida the year before the program began. There was no public health emergency around dengue in Florida, but there is now. So then we come to Bali. The World Mosquito Program have decided that Bali, I think, because it's a famous, iconic island, will be a good poster child, more famous than Georgia, for spreading their programs around the world. They propose bringing it here, and initially they want to put it in North and South Bali and Denpasar and Buleleng. And they've started a community campaign, but it was very limited in terms of extent, and there was very little wide consultation. And only because of the activities of a social media group begun by Professor Klaproth and 2 experts here in Bali did more Balinese hear about it. Now, what we know about the Bali program, I've put on this slide. There was a plan to release them from November the 23rd. That has been now postponed because of community pressure. We know that the Aedes aegypti to be introduced here are more resistant to pesticides and other species of mosquito, because that's a feature of Aedes aegypti as they've evolved. We know that there were 44 areas, 1,300 households. We know that in order for the project to be successful, Balinese would have to receive billions of mosquito bites. So effectively, the Balinese will become lab rats for the project. We also hear that the conventional detergent debate for reducing mosquito larvae in standing water is less available in Bali now than it was before they planned to start the program. We also know that no permission was obtained for the extension of the project to Bali, either from the Coordination Authority in Jakarta or from the Balinese at large. As in Georgia, consultation was confined only to the areas where it was planned to incubate and release the larva. There was no Bali-wide consultation of community and spiritual leaders and so on, which is very concerning. As I say, I have worked on genetic engineering of organisms since 1998. I work with Ian Wilmot, who cloned Dolly the sheep, the first cloned mammal, in producing this edited book, which was the first book on the ethics of genetic engineering. I later went back into the field, and we looked in this report, we reported on field work in 3 countries, Mexico, India, and Brazil. And in that field work, we discovered that just as we had said in this book, many of the unanticipated consequences, many of what we thought of as hazards from introducing genetically modified species into the wild had occurred in Brazil, Mexico, and India. One of the most striking was the formation of mutant weeds in soya and corn crops in Brazil, which were resistant to all pesticides, which grew to 10 meters high in some cases, and which farmers were finding incredibly difficult to eradicate. Well, about the barley program, then, there are many risks and unknown. There's only one peer-reviewed published risk assessment of mass releases of mosquito, and it's non-empirical. It simply uses a computerized Bayesian model and says there are no risks. There are significant. However, the health impacts of massive release of Aedes aegypti in South and North Bali are therefore unknown because there was no risk assessment. Furthermore, experience with agricultural genetically modified organisms indicated it's likely that a novel mosquito monoculture in Bali will create the emergence of stronger pathogens later. And this has already happened, as you saw in Brazil, where you have now a strengthened strain of mosquitoes which are more resistant to pesticides and more difficult to wipe out. And this is what I predicted would happen in Bali. Those pathogens we might see a reduction in dengue for a few years, but we might then have a plague on our hands far worse than what we had in the past. There were only 10 deaths in total. There were over 1,000 serious injuries and deaths on motorbikes. So if we wanted to improve public health in Bali, there are much bigger priorities than dengue, it seems to me. Ecological and spiritual impacts of this genetic modification of Bali's mosquito population on the UNESCO World Heritage by referring to that, because I see parallels between the Bali Mosquito Project and the Bali Irrigation Project. In the 1970s, engineers and bureaucrats from Jakarta and Switzerland came to Bali and said they knew better than the Balinese how to grow rice. They told the Balinese to abandon their old temple-governed rice-growing techniques and ceremonies, to plant as many times of the year as they could and ignore their calendar, the neighbors, and the priests. The engineers who introduced these techniques knew nothing of the evolved ways and the spirituality of Bali. They dismissed the Balinese as having a rice cult and saw no value in Balinese age-old rice-growing techniques. Balinese were even fined if they tried to follow the traditional system. But things went wrong very rapidly. They got famine, they got drought, they had more pests, and the Balinese started to campaign for a return to the traditional rice-growing system and got the backing of Udayana University in Denpasar, which challenged the continuous under-coordinated rice planting recommended by the scientists. Eventually, as an anthropologist wrote a report for the Asian Development Bank, Stephen Lansing, and he said that he thought that the rituals of the water temples were not a template for an outmoded cultural system of ecological management, but had deep roots in Balinese culture, and that the hydraulic solidarity of the temple system was more effective than the scientific system. He wrote a book later which he called Priests and Programs, and argued that the high-tech bureaucratic solution to increasing Balinese rice growing was in fact highly problematic and failed to recognize the intrinsic merits of the traditional regime of rice growing here in Bali. And it also failed to recognize that religion could play a role in agriculture, because that was inconceivable to development planners. Well, eventually, the Swiss engineers admitted what they dismissed as a superstitious water culture Bali was more effective in growing rice than their scientific techniques. They left behind hybrid sea concrete wills, but they gave up efforts to replace the water temples and the priests. The failure of the Bali irrigation project and the triumph of the Subak system demonstrates that what Western scientists and Jakarta bureaucrats dismissed as magic is a real energetic force field. The Bali Mosquito Project, however, will hardly be reversible if later it is found to have similar problems, because it will permanently genetically alter the insect population in the Subak system of Bali, contrary to Bali's spiritual beliefs. And this is why many of us have been campaigning here and drawing to the attention of the newspapers against the introduction of these mosquitoes here. Richard Klaproth has been an absolutely courageous leader in this project, and it has led to a temporary halt in the project. But we're already seeing advertisements by World Mosquito Program here in Bali promoting the project in English to tourists and suggesting that they will return to it at a later date. We want to say no. We do not want these engineered mosquitoes introduced into Bali. Thank you very much for listening and for the invitation to be with you today.
Thank you. Thank you, Prof. Michael. Yeah, we are now clear. Yeah, about the situation.
Itu dihancurin loh, dia penelitinya.
Yeah, I will talk in bahasa now. Ya, jadi tadi Prof. Michael menjelaskan secara clear, ya, secara jelas, ya, bahwa ini adalah genetic engineer, ya, jadi rekayasa genetik, dan ini bahkan ini adalah merupakan bagian dari gene drive, ya, tadi disebutkan. Dan gene drive ini sangat berbahaya di berbagai negara, tadi disebutkan. Ini menimbulkan masalah yang sangat besar. Kemudian yang kedua, dia juga melihat, ya, mengamati adanya kejanggalan di dalam grafik yang ditunjukkan kejadian setelah penyebaran, sebelum dan setelah penyebaran nyamuk Wolbachia. Jadi ada peningkatan yang sangat tidak wajar sejumlah 2,5 kali, ya, dari yang aslinya. Jadi kalau dilihat di tahun sebelumnya di 2012 itu ternyata hampirnya sama, angkanya sama dengan di tahun 2022, ya. Tetapi di tengah-tengah ini dia melihat berbagai kejanggalan. Kemudian yang berikutnya adalah kenapa juga selalu disebutkan bahwa penyebaran nyamuk ini tidak berbahaya, ya. Tadi diperlihatkan beberapa situs yang menunjukkan bahwa penyebaran nyamuk Wolbachia ini bermasalah besar, ya, menimbulkan wabah di Sri Lanka, ya. Tadi disebutkan jumlahnya 3 kali lipat, ya. Bahkan saya juga melihat ada kenaikan 2000% dari tahun 2022 ke 2023. Kemudian juga di Singapura, ya, dan di beberapa negara lain. Tadi disebutkan juga Brasil, Florida, Texas, dan lain-lain. Nah, ini yang membuat kita juga perlu mengedepankan kehati-hatian, resiko, kewaspadaan. Dan Profesor Michael tadi menyebutkan bahwa dia tidak setuju, ya, untuk penyebaran nyamuk Wolbachia ini karena dampak negatif yang resikonya itu berpotensi dapat ditimbulkan sangat berbahaya. Mungkin saya bisa simpulkan itu.